Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to Chapter 2.4, the Power Rule. We'll start by making a table of common functions and their derivatives. Now, we're not going to use the definition of the derivative anymore. That's a thing of the past. We're going to work on these shortcuts. And I'm going to start in the middle of this table with the function x squared, and we'll work our way backwards at the end. For now, let's start with x squared, and if you did the definition of the derivative, you would find out that f prime of x is 2x. If we did it for x cubed, you'd find out you get 3x squared. You did it for x to the fourth, you probably already recognize the pattern, you get 4x cubed. If you took this pattern and extended it to the general case, all the way down here to x to the n, well, we notice in our pattern, hopefully, that all we do is we take that exponent, multiply it down, so it'll be n times x, and then in all these cases up above, you see how we just subtracted 1 from the exponent, so it'll be n times x to the n minus 1. And this is, in fact, exactly what we're talking about today, the power rule. So just writing it a little bit more formally, if you have some function y equals x to the n, its derivative will always be n times x to the n minus 1. Now I want to go back in this table before x squared to look at a couple simpler examples, more basic examples, and now that we have the pattern from x squared on, these will make a little bit more sense. So if we look at just x to the first, following the power rule, we would multiply that 1 down in front, subtract 1 from the exponent, making it now x to the 0. But we all know x to the 0 is just 1, so this is going to end up just being 1. So the derivative of x is just 1. If we look at a constant term, well, let's just call it k. Since it doesn't have any x's in it, we could say it's x to the 0 power. And if we follow the power rule, we would just multiply by this power of 0. And if we multiply anything by 0, who cares what it is? 0 times what's left over is going to be 0. Okay? So it's actually one of the simplest situations that you could run into, but people always mistake it and don't think of it that it works like a power rule, but it does. And because it's so common, we give it its own name, and we'll just call this the constant rule for derivatives. The derivative of any constant is 0. Now this should make sense, because when we're talking about the derivative, we're talking about a slope. And a constant function, that's just a horizontal line. What's the slope of a horizontal line? 0. Let's take our newfound shortcut and apply it to a couple examples. Let's start with something akin to what we have in the table here. Y equals x to the 8th. Power rule says we take the derivative by just multiplying by the power and subtracting 1 from the exponent. That should get us y prime is equal to 8x to the 7th. Right. Second example, a little bit harder. We had the function y equals 1 over x cubed. Now you can't just apply the power rule here because it doesn't look like x to the power of n, it's 1 over. So we do have to rewrite it with a negative exponent as y equals x to the negative third. And now that it's in the right formatting, we can apply the power rule, multiplying by the exponent of negative 3 and subtracting 1 from the power, leaving us with negative 3x to the negative fourth as our derivative. Lastly, let's take a look at one more example, but this time let's include some radicals. Y equals the cubed root of x squared. Again, we cannot simply apply the power rule at the moment. It's not in the right formatting. So if we rewrite it with a rational exponent, that'd be y equals x to the 2/3 power. Now it's a power rule situation. We can multiply by the exponent of 2/3 and subtract 1 from the power. So 2/3 minus 1 would be, that'd be negative 1 over 3. And there's our derivative following the power rule. Hopefully you can see the value of this rule. Before, using the definition of the derivative, these problems would have taken 3-5 minutes to do on your own. With the power rule, we can take the derivative of any function in this formatting very quickly. Make sure to check out our next video where we learn the basic properties of differentiation, which allow us to apply this power rule in a wider variety of cases. Don't forget to hit subscribe and like the page to get alerts about all the content we release each week.